Hi folks, it's HESSEL. So this is a solutions walkthrough for the A+ Physics worksheet called Kinematics Defining Motion. In case you don't have the worksheet, here it is. I'm just going to scroll the pages. Here's numbers 1 through 8. Here's numbers 9 through 17. Then we have 18 through 26, 27 through 35, 36 through 38, 39 through 42, and number 43 and 44. So there you go. And we'll begin at the beginning with number 1. So number 1 addresses distance and displacement. Remember that distance is a scalar. Direction doesn't matter, so you simply just add up the amounts. I have 4 plus 3 plus 4, so that distance is going to be 11 blocks. But displacement is a vector, and it's from start to finish, straight line, straight arrow from start to finish. So as we travel from home to school, we have 4 blocks east, 3 blocks north, and 4 blocks east. So if I draw my resultant, here's the resultant, straight line, start to finish, right there. I can use some right triangle trig to figure out that the magnitude of that resultant is 8.5 blocks. But I don't even need to do that because it's just asking less, greater, or the same. And I can see that that purple arrow right there is a much shorter magnitude than the original distance of 11 blocks. So compared to the distance she walks, the displacement is going to be less, choice 1. And yeah, the displacement could be equal to the distance if you travel in a straight line without changing direction, but typically the displacement is less than the distance. It's never the other way around. The displacement is never more than the distance. Okay, number 2, we got this guy in a boat, and it has 2 vectors, 5 meters per second east and 3.3 meters per second south. It frequently helps to sketch or draw a problem, especially for this one. So those are the 2 vectors in question. The 5 meters per second is flowing to is the boat's engine pushing it east. It said that's how it goes in still water. So that's the boat's engine. And then the current, though, is pushing it to the south at 3.3 meters per second. If I do a quick tail to tip, I can see what the resultant velocity is. So there's the resultant, and that makes a right triangle, and we know for vectors that are at right angles, if I want the magnitude of their resultant, I use Pythagorean theorem. Write the full equation without substitution first. Substitute the numbers in with their units. And when you round it, the final answer is 6 meters per second. That's choice 3. Speaking of 3, number 3, it's talking about a speedometer, and it's asking about speed and velocity. Well, a speedometer measures speed, and a speed is a scalar, which does not have direction. Velocity is a vector, and it does have direction. So basically it's asking about velocity, and that's choice 1. Velocity is a vector that has a direction. Number 4, talking about fireworks. It gives the distance that the sound travels, it gives the speed of the sound, and it wants the time. And it says the time between seeing and hearing. You can assume that when you see it, it's practically instantaneous. The speed of light is 300 million meters every second. So yeah, we're going to call that instantaneous. So really what it's asking about, it's talking about the speed of sound. So they give us a distance and a speed, and they want the time. First thing we do with a problem like this is we write our givens down. So we have a distance and a speed, now we have an unknown, and you choose your equation based on the givens that you're given and the unknown that you're looking for. We don't have a lot of equations yet, so really, in terms of motion, we really only have one, v equals d over t. So we plug in and solve. Remember to write the equation first, then we put the numbers in with their units. Now there is a twist to this otherwise simple problem. They gave the distance in kilometers, but the speed is in meters per second. I'm going to have to convert the kilometers to meters. 1 kilometer is 1,000 meters, so 3/4 is 0.75 kilometers is 750 meters. And I want to keep all my units the same, so that I got to convert to meters since my speed is in meters per second, not kilometers per second. I guess you could call the 340 meters per second 0.34 kilometers per second, but either way, you got to keep all the units the same. Cross multiply to solve for t, you wind up with 750 divided by 340, 2.21 seconds, 3 significant figures because the original numbers were 3 sig figs, and there it is, choice 2, 2.21 seconds. V equals d over t, by the way, is a formula. It's the first formula on the back page, the mechanics page of the reference table. Do not switch d and v. It's v equals d over t, not d equals v over t, which those are frequently transposed, but the formula's on your reference table. So if ever you're not sure, check your reference table. Number 5, we're going to skip for now. I mean, mass stays the same, the mass doesn't change, but I want to talk about mass and weight when we get to mass and weight. So let's look at number 6. Okay, I got a plane, they give me the velocity, and then they give me the angle, and they want to know what's the magnitude of the eastward components of the plane's velocity. I think a picture would be useful here. Now, kilometers per hour, we usually deal with meters per second, but don't worry about converting those velocity units because the answers are in kilometers per hour too, so we don't need to deal with that. But this angle, 30 degrees south of east, it's an interesting way of posing that angle, but take it literally. Start from east and go 30 degrees south of east. So yeah, actually that vector is not going to the right. Let me fix that. So that's what 30 degrees south of east looks like, starting from east and going 30 degrees south of it. The actual angle from 0 would be 330 degrees. Now I suppose you could draw this with a ruler and protractor and actually solve for the eastward or horizontal or x component using a ruler and protractor, but I'm just going to use the x component's equation. It's on the back page of the reference tables. And I'm choosing x component because east is horizontal. We can see the direction east is horizontal, and so that's going to be a horizontal or x component. Now theta, if I put in 30 degrees, I'm going to get a positive answer. The actual angle from 0 is 330 degrees, which I'll still get a positive answer, because in the fourth quadrant, x is positive. So let me just keep things simple. I'm just going to put in the 30 degrees. We're just looking for the amount of the x component. That's really all they're looking for.
Making a video for your class?
Yeah, I'm making a video for my class. That's my son. And so I put the numbers in with my units, and then I put the angle in with the degree symbol, because that counts as units, and be in degree mode in your calculator and figure out the magnitude of the x component. And again, let me highlight how I showed the work. I wrote the equation first, I put the numbers in with the units, and my final answer has units too. Choice 2, 650 kilometers per hour. Next, number 7. So 7 says that we've got 2 cars, one going 40 meters east in 5 seconds, and a second car going 64 meters west in 8 seconds. And it wants to know what's the same about them. Well, first choice is average velocity. I know that's not true because velocity requires direction, and they have different directions. One's east and one's west, so it's not choice 1. And then number 2, not only they don't have the same distance, let alone the same displacement. First guy went 40 meters and the second guy went 64, and they went in different directions. Definitely not choice 2. Choice 3, change in momentum. Change in what? We haven't talked about momentum yet, so that's not going to be the answer. Momentum is mass times velocity anyway, but yeah, we haven't spoken about it. It's also not true. Well, I actually don't know if it's true because I don't know their mass. But yeah, it's not changing momentum. But speed? Yeah, it's going to be the same speed, but let's do the math to see why. So yeah, when we work the math out, we find out that their speed, the both of them, they went 8 meters per second. Car 1 went east and car 2 went west, but they're talking about speed. Direction doesn't matter. So 7, choice 4, same average speed. 8's easy. I wish I had just enough room to get it on the previous page, but it wants to know the 2 things that define a vector. All vectors have magnitude and direction. And magnitude means amount. Don't forget that. And don't forget that you need units in your magnitude, and direction can be as simple as positive or negative, up, down, left, right, or north, south, east, or west, or even an angle from 0 to 360, like we saw before with that 30 degrees south of east. First page is done. Let's go to the next page. Now we got to figure out the scale in this vector diagram. And this one's a little funky because the scale depends on what your page looks like. There was a fixed official scale for the Regents exam, but for this guy, I'm just going to measure. I just held up a protractor to my computer screen here. Not a protractor, a ruler, metric ruler. And my screen and my ruler say that the 1.5 meter per second vector is 10 centimeters long. So however you measure it on your screen or on your page or whatever, let's look at a conversion ratio to figure out what the scale actually is. I don't need to do it for the 0.7 meter per second vector because it's on the same page, it's on the same screen, it's going to use the same scale. So if I cross multiply, and I don't really need to because the denominator here is 1, but if I do 1.5 divided by 10, I get that a centimeter is 0.15 meters per second. That's a bit of an awkward scale. I think the official Regents answer that was on the Regents exam that year was not that awkward. But either way, you can use a conversion ratio to solve for x and figure that out. So 10 wants us to construct the resultant vector. You could do that with parallelogram method, or you could do that with tail to tip method. I'm going to use tail to tip because it works every time. They list the 1.5 meters per second first, so I'm going to draw that first. Using my scale, that's going to wind up being 10 centimeters long. To be honest, I'm just going to use boxes on my screen right here because it's not really going to matter. Besides, I'm going to find the magnitude of the resultant. I could do it graphically. I'm actually going to do it with Pythagorean theorem, but I'll explain both. Also, I gotta be honest, even though they use a particular scale on the sheet, number 10 does not tell you what scale you have to use. So if you want to use something simpler, you can. So there's the resultant. I just reread the problem, and it says, on the diagram above, use a protractor and ruler to construct a vector to represent the resultant. So I guess I have to use their diagram. So let me show you how to do it both ways. There's the tail to tip. Here's what it would look like if it was parallelogram. There you go. That's the resultant. 10 just says draw the vector. It doesn't say find out anything about it. So there's 10. There is the vector. 11 and 12 is when they want to know about it. So 11 says find the magnitude of the resultant velocity. You could measure that with your ruler and work back with your scale, but these are right angle vectors, so I could use Pythagorean theorem for this. Square and add them up, square root 1.7 meters per second. Also pay attention to the way I showed the work, formula, unit substitution, and unit with the answers. Units with the answer. So 12 we have to read very carefully here. It says determine the angle between north and the resultant velocity. So they do not want to know the angle from the x-axis, which is usually how we measure angles. No, they want to know what is this angle right here. They want to know what that is. So what you do is you take your protractor and you line it up like a D. Let me show you what I mean by that. Line up your protractor vertically and then see what this angle is. This guy right here. Measure that. And if you drew it properly, it should be somewhere around 65 degrees. So that's the answer to number 12. 65 degrees. Okay, next, number 13. I'm averaging about a minute per question. Not really. I'm actually falling a little bit behind, so I should stop making commentary like this. 13. Okay, so the batter runs to first base 27.4 meters, overshoots by 3 meters, but then comes back to first base. So distance, remember, you can't take it back and there's no direction, so you simply add it up. So the distance here would be 27.4 plus 3 plus 3. Distance is 33.4 meters. But displacement is start to finish, so start to finish from home plate to first base is only 27.4 meters. So yeah, that displacement is 6 meters less than the distance, and that is 6 meters shorter, choice 2. Again, just be careful as you read. If you read this the wrong way, you could think that it's talking about, it says compared to the displacement the distance is. That's not what it's saying. Compared to the distance, it's asking about the displacement. Please read carefully, because you can know the physics, then just simply misread the question and get it wrong. Yeah, if anything, that's the number one problem with Regents exams. After units, units is actually not even number one. The number one problem, the number one thing that kids get wrong on a Regents exam is not reading the question properly. Be careful. 14, good question. 14 gets at the fact that average speed is total distance over total time. You don't take the speed of each leg and average it. The reason why, you can only do that if they were all the same length of time, but they're not all the same length of time. We have 5.9 minutes, 6.2 minutes, 6.3 minutes, and 6 minutes. So each leg of this race is different times. The way you figure that out, so you don't have to take like a proportional average or something crazy, just add up the total distance, the total time, do the division, there's your answer. And normally we don't do kilometers and minutes, but the final answer is in kilometers per minute, so I don't need to convert anything. Choice 1, 0.16 kilometers per minute. 15, I got 10 meters north and 30 meters south. What's the displacement? 10 meters north, 30 meters south. Displacement from start to finish is 20 meters south. That's choice 1. 16, which one's the vector? Well, you should remember the mnemonic, MAD5, which lays out all of the vectors. Here it is. MAD5. Momentum, acceleration, displacement, forces including weight, impulse, velocity, and all the fields, electric, gravitational, and magnetic fields. MAD5. So yeah, that's the best mnemonic I've seen, or like our way of remembering the vectors. If you think of something better, please let us know, because this one is okay, but not great, but I haven't seen any better. Anyway, displacement is in that list, so the answer is choice 4, displacement. Also, anything not in that list, like mass and time and distance, those are scalars. There are more scalars than there are vectors. 4 meters east, 4 meters north, find the displacement. We've seen this type of problem before. Let's just bang it out and move on. Resultant displacement from start to finish, there it is. They're at right angles, so they want the magnitude of the displacement only. They don't want the angle. It's 5.7 meters. Next. 18, here's another one. Find the scale. Well, I can hold up a ruler and let's see what we get. And I can write down a conversion ratio to figure out the scale. When I held the ruler to my screen, I got that 8 meter vector was 4 centimeters long. When I divide it through, that gets me a scale of 1 centimeter is 2 meters. My sketch here is not to scale, but you would get the point. You have 8 meters or 4 centimeters going up, and then 6 meters or 3 centimeters to the right, and you sketch your resultant in using tail to tip, and that's the way it would look. And then of course number 20, once the magnitude of the displacement, you can use the scaled vector diagram to figure that out, but they're at right angles, and so you could just bang it out with Pythagorean theorem. Why not? 10 meters, and if you're astute, you might recognize that these are multiples of 3, 4, and 5. 3, 4, 5, right triangle, there you go. 21 is just like 14, to average speed is total distance over total time. I don't need to convert kilometers and hours because my answer is in kilometers and hours. I'll do the math and move on. 85 kilometers per hour. I will point one thing out though. Notice I went from the word speed to the letter V. I did that on purpose because V is for velocity, but the magnitude of velocity, the amount of velocity, is speed. So we use V for velocity and speed, so don't let that trip you up. Difference between a scalar and a vector: vectors have direction, scalars don't. The end. 23, they give a vector and they kind of want the components of that vector. Notice that the resultant is pointing to the upper left, so I'm going to want components that are going up and left. You know, even if it's like kind of up and kind of left, well, take a look at your choices. Choice 2, the two vectors, they're the same length and they oppose each other. They're going to cancel, so forget about choice 2. Choice 3 looks promising. I have up and right. Nah, that's going to set me off to the upper right. It's first quadrant, not what I'm looking for. And then 4, now that looks interesting. It's a little V situation. But those guys there are also going to go to the upper right. No, my answer is choice 1, and let me sketch out why. So there's the resultant that I'm talking about. And here's how choice 1 is going to be the components of that resultant. A little parallelogram action. Components. Well, will you look at that? So AB going up and to the left is going to give me a resultant that's going to go up left. Keep in mind, I'm not saying it's like, oh yeah, A and B are going north and west, so they're going to give me a resultant that goes northwest. Be very careful there. That's only true if the two components are the same length and the angle is exactly 45 degrees. Northeast, northwest, southwest, and southeast are 45-degree angles in their respective quadrants. So if it's, say, like quadrant 1 and it's 30 degrees, don't say northeast, because northeast would be 45 degrees. So be careful with that. So 24 and 25 are based on the same information. So I got two velocities here and a displacement. They're talking about a stream. I feel like I need a picture, a sketch of the stream. So there's my stream. It's 30 meters wide, and I got the boat that's going across the stream from the west to the east. It's being launched from the west side, but the velocity is to the east at 2 meters per second, and then the stream is flowing southward. It's pushing the boat southward, that water, the flow of the water, at 1.5 meters per second. So first it wants to know the resultant velocity. We have two vectors at right angles. I can use Pythagorean theorem to figure that out. So there's the answer to 24. It's choice 2, 2.5 meters per second. Now 25 is supposed to be a simple question, but people always mess this one up. It says how much time is required for the boat to reach the opposite bank of the stream. Well, I know from one bank to the other bank is 30 meters, so that's how far it needs to go. Then it wants to know what's the time. And we can use v equals d over t to figure out the time, but I have a bunch of speeds here. I have a downstream speed of 1.5 meters per second, I have a cross-stream speed of 2 meters per second, and I have a resultant from those two velocities of 2.5 meters per second. Well, if I'm trying to cross the stream, I actually don't care what the southward flow is. That stream could be flowing quickly, that stream could be flowing slowly. It's still going to take me the same amount of time to cross the stream. If the stream is flowing slowly, then I'm not going to go that far downstream. If the stream is flowing quickly, then I'm going to wind up pretty far downstream. It's not asking about downstream, it's asking about crossing it. So the only velocity that matters here is the velocity crossing the stream, the 2 meter per second velocity. So yeah, this is a really simple equation, but I think that 25 is actually quite a difficult problem, because you have to realize that for crossing the stream, only the cross-stream velocity matters, even though you just solve for the resultant. And then if you use the resultant velocity of 2.5 meters per second, you end up with a time of 12 seconds, which is an answer choice. They do that on purpose so that, if you go to solve for an answer and it's not there, then you know you're wrong. But the most common wrong answer is there, so they don't tip you off that you're wrong. I mean, it's a multiple choice thing, whatever. But yeah, so we wound up use the cross-stream velocity of 2 meters per second, the 30 meters across the stream, and you get across that stream in 15 seconds, choice 3. 26 is interesting because they give two displacements and a time, and they want to know the magnitude and direction of the person's total displacement. Guess what? The time doesn't matter. If they wanted velocity, the time would matter, but they didn't say that. They just want the displacement, so the time is a distractor. 150 meters east, 30 meters west. Resultant is 120 meters to the east. I'll write that the time was 10 minutes, but it really has no bearing on the problem. 27, a seemingly simple problem with a twist. You have to read carefully. They give a distance, they give a time, they went to speed. V equals d over t and be done with it, right? Hold on. Alright, 300 kilometers, 3600 seconds, V equals d over t. 300 over 3600, not so fast. That's kilometers, and you could be like, alright, well, what if the answers are in kilometers per second? They are not. The answers are in meters per second. So you're going to have to get those kilometers into meters. And there are 3,000 meters in every kilometer, so 300 kilometers is actually 300,000 meters. There we go. 300,000 divided by 3,600, and we get a speed of 83 meters per second. And then there's one more detail, actually. You'll notice that the answer choice is not 83, but 83.3. And here's why. Let me fix something in how I wrote this problem out. That's 3.60 times 10 to the 3, so that's 3 sig figs. And at 3 significant figures, that gets me 83.3 meters per second as my official answer. And that matches choice 4 exactly. As I've said before, you guys aren't going to be held to significant figures on your shown work for part B, 2, and C, but they do follow significant figures on the answer choices for multiple choice, and that's a great example right there. So 28, you got 5 meters north, 4 meters east, and 2 meters south. There's two ways you can do this. You can do it as a 3-vector tail-to-tip problem. You could do it that way. Or you could just turn this into a right triangle by saying 5 meters north and 2 meters south is really just 3 meters north. So 3 meters north and then 4 meters east. And if you know your right triangles, this is a 3, 4, 5 right triangle. 5 meters, choice 2. Scalars and vectors. Scalar does not have direction, a vector does. And so on the choice 1, speed is to velocity. Speed is a scalar, velocity is a vector. Now displacement is a vector and distance is a scalar, but it says scalar vector, not the other way around. Displacement and velocity don't measure the same thing, and speed and distance don't measure the same thing. So if we're saying scalar vector, speed, velocity, just be careful. I've heard people say things like, a scalar is speed, or scalar is distance. Those are examples of scalars. Right? A scalar is just some quantity that doesn't have direction. Just as you would say, like, oh, vector, yeah, that's velocity. Velocity is an example of a vector, but force is a vector, impulse is a vector, so be careful of using examples to define something. But yeah, there's 29 for you. Now 30 is an interesting question because we have 2 displacements, 2 times, we have 2 different directions, and it's talking about velocity, not speed. So let's take a look. First we have 90 meters north in 15 seconds, and they say in the problem that the time is 20 seconds. So really we have to get the total displacement, and the direction matters here. The distance would just be 90 plus 40, so the distance would be 130 meters, and the speed would be 130 over 20. It's not the speed, we want the displacement. So, and we have 2 different directions. So 90 meters north and 40 meters south. South is like negative north. So that displacement is 90 minus 40, 50 meters north. Let me sketch it out to show you what I mean. 90 meters north, 40 meters south, net displacement 50 meters to the north. V equals d over t, so that's going to be 50 meters over 20 seconds, giving us 2.5 meters per second, choice 1. Notice that if you accidentally found the speed and did 130 over 20, that would be 6.5, and oh look, that's an answer choice. So be careful. Okay, these videos go up to 30 minutes. I'm still under time at 1 minute per question, so go me. But there are more questions in this worksheet. It goes up to 44. I don't have 44 minutes, so I'm going to have to do a part 2 video, and that's coming up soon. Thanks.